All right, guys, so we're going to talk about inverse functions. And what I'm going to do is I'm going to show you how to find the inverse of a function algebraically. I'm going to show you the relationship when you graph inverse functions. And then I'm going to show you the relationship between the domain and range of inverse functions. So let's start with this first one. We got f of x is equal to 3x plus 1. Well, you know that f of x is equal to y. So I'm just going to say that y is equal to 3x plus 1. And the reason why I'm going to do that is because in order to find the inverse, what I'm going to do is I'm actually going to switch x and y. So I'm going to say that x is equal to 3y plus 1. So again, I'm switching the x's and the y's. And what I'm going to do is then resolve this for y. So in that case, I would go ahead and subtract the 1 here. And I get x minus 1 is equal to 3y. And then, of course, I'm just going to go ahead and divide both sides by 3. And I'm just going to write it this way. Y is equal to 1/3 x minus 1/3 because I have x over 3 and then negative 1 over 3. So I'm just going to write it as a fraction like that. So this is the inverse, which we can say, we'll write it this way, f inverse of x in function notation is 1/3 x minus 1/3. So now let's take a look at this graphically. If I were to graph y equals 3x plus 1, so if I put in 0 for x, I get 1. If I put in 1 for x, I get 4. Then we can do the negative side. If I put in negative 1, I'm going to get negative 2 right here. Basically, you can follow the slope of 3, up 3 over 1, up 3 over 1. So I'm going to go ahead and make that line, see how close I can get, try to straighten that out. There we go. So this right here is f of x, the original. Now, if I go ahead and graph the inverse, so I have this right here. And if I put in, let's say I put in the value of 1 for x, that's going to be 1/3 minus 1/3, which is 0. And then I could just use the slope of 1/3, so go up 2 and over 3, and then up 1 and over 3, sorry, and then down 1 and over 3 here. 1, 2, 3. And then I'm going to go ahead and do that line. Oh, didn't want to straighten up for me. Sometimes it's a little fickle there. There we go. So this is the inverse, so f inverse of x. So now what is that relationship? If you can notice this, there's actually a line of symmetry. There is a line of symmetry. And what that line is, and let me switch, I think I can do this. Switch it over to, hang on one second. There we go, I want a dashed line. Let's do that. So this, perfect. Right here, this is the line, switch back to solid. The line y equals x. So this is the line y is equal to x. And you'll notice if I were to fold the graph on the line y equals x, these points would all overlap. They're symmetric to the line y equals x. That is the case if you have inverse functions. They will be symmetric to the line y is equal to x. So if you are just looking at it in terms of graphically, just look at the line y equals x and see if the graphs are symmetric, and then you know if you have inverse functions. Now let's talk about domain and range. So the domain for f of x is going to be all reals because it is linear. And the same thing for the range of f of x is also going to be all reals. Now, this is not the best example to discuss domain and range of inverse functions, but what you're going to see that is the domain of the original function f of x is actually going to be the range of the inverse. Now, in this case, everything is all reals. You'll see in other examples, it'll be more clear. So whatever the domain is of the original function, f of x, that is going to be the range of the inverse. So you don't even have to find the inverse to determine the domain and range. All you have to do is look at the domain and range of the original. So the range of the original is going to be the domain of the inverse. And of course, again, these are all reals, so not much is going to change. Sorry about that. All right, so let's look at another one where that's going to come into play. So let's look at this second function. We got f of x is equal to the square root of x plus 2. So I'm going to go ahead and put in my y, because I'm going to do this algebraically first, and then I'm going to go ahead and switch x and y. And now I'm going to resolve for y. So what I'm going to do is I'm going to square both sides. So I get x squared is equal to y plus 2. Then I'm going to subtract the 2. And I get x squared minus 2 is equal to, and we're going to say that is the inverse, because that's the y value, but it's the inverse that we just found. So f inverse is equal to x squared minus 2. So now let's take a look at this graphically. So let me graph the original one, f of x. So if I graph f of x, which is the square root of x plus 2, that's going to start here. And then if I put in the value of 2, that'd be the square root of 4, which is 2. And that's good enough to get a good picture right here. So it's going to look roughly like that. Quick sketch. Now, before I do anything about graphing the inverse, let's talk about domain and range. And we're going to talk about that for a specific reason. So if I have the domain of f of x, so if f of x is the square root of x plus 2, then we know that the domain of this is going to be x is greater than or equal to negative 2. You can see that graphically it starts at negative 2 and then goes all the way to the right. Or you could just take what I always tell my students is just when you have a square root, you just take what's inside, set it greater than or equal to 0 and solve it, and that'll be your domain because you can't have a negative inside the square root in terms of the domain. So then let's talk about the range. So the range of f of x, you can see that it starts at 0 for y and goes all the way up. So therefore the range is y is greater than or equal to 0. So why does that matter? Because now we know that the range of the inverse is going to be whatever your domain is for f of x. So then if the domain of f of x is greater than or equal to negative 2, that means the range is going to be y is greater than or equal to negative 2 for the inverse. See how the values are the same. Of course, this has to be a y as opposed to an x because it's range. That means that the domain of the inverse is going to equal what this is here, but of course with an x, so x is greater than or equal to 0. Well, why did I do that before I graphed? Because if this is my domain, I can only graph the inverse on its domain, which means I can only start at 0. I can't graph the whole thing. Yes, if I took x squared minus 2 by itself and graphed it, you would see that it would look like a parabola like this, right? The problem is our domain is only from 0. Let me change the highlighter. My domain is only from 0 to infinity. So I can only include that highlighted piece in the domain. So when I graph this and I only have 0 from my 0 to infinity, I'm going to be at negative 2. And then I can put in, if I put in 2, which would be at 4, and then 4 minus 2 is 2, that puts me right back here. So now I am actually crossing this value here and going up, and that's pretty close. And now let me graph the line y equals x. See how close I can get here. Pretty close. And switch that back. And then you can see that if I were to fold this on the line, these would all overlap. Now I know from here to here, it doesn't look like it's exact. These graphs are a little bit off, but you can see how this point would overlap with this point. These actually cross in the same value. So you can see that it's symmetric to the line y is equal to x. So that's why it's important to understand the relationship between the domain and range of functions and their inverse. I could not graph this right here. I could not graph the whole thing. It would be a parabola, and if I did that, then you would see it wouldn't be symmetric, because you would have this extra piece, and I'll just do a dash. You would have this extra piece over here that would form the parabola, which means that it wouldn't be symmetric to the line y equals x. All right, let's look at this last problem here. I gave you just linear, and you had a square root. Now let's look at absolute value. So let's say y is equal to absolute value of x plus 3. I'm going to go ahead and switch. So x is equal to y plus 3. Now when I solve this, remember with absolute value, you got a positive and negative case. So in order to solve this, I'm going to say that x is equal to y plus 3. I could just go ahead and get rid of the absolute value. Then I'm going to do the negative case, so I say negative x is equal to y plus 3. Now I'm just going to solve those. So when I do that here, I will get x minus 3 is equal to y. And then over here, I'm going to get negative x minus 3 is equal to y. So therefore, I have f inverse is equal to x minus 3. And on this side, I have negative x minus 3. So now we can write that as a piecewise function and say that it's equal to x minus 3 and negative x minus 3 for x is greater than or equal to 0. So now you might be saying, well, where are you getting that for x is greater than or equal to 0? Remember that we have to deal with the domain and the range based on the original function. So I'm going to go down here. The domain of f of x, which is the square root of x plus 3. Well, what is that domain? If you're looking at the absolute value, domain is going to be all reals. It's absolute value. What's the range of f of x? Now, maybe I should graph that first. So the absolute value of x plus 3, that's going to be starting over here at 3, and then it's going to keep going up and over 1. So it's going to look something like this. And then, see if I can get this one here. That. So hopefully you can tell from the graph that the range is going to be y is greater than or equal to 0. Well, what does that mean? That means that the range of f inverse of x is going to be all reals. And then the domain of f inverse is going to be x is greater than or equal to 0. So now you can see where this comes from. The domain will limit to x is greater than or equal to 0. So now if I am going to graph this right here, this function, I'm graphing these when only x is greater than or equal to 0. Now these are both linear. If you take them separately, you get x minus 3. Well, starting at 0, plug that in, that's going to be negative 3, and then it's going to keep going up with a slope of 1. This is the same thing. It's going to start at, if I put in 0, start at negative 3, but then have a slope of negative 1. It's going to go down like this. And look what you see. It is basically your absolute value on its side. Pretty close. And now, if I draw my line, so y is equal to x, the symmetric line, you can see that if I were to fold it on this line, all of these points, everything would overlap. It's symmetric to the line y is equal to x. But again, this domain and range piece is important because graphing the inverse, you have to make sure you're adhering to what the domain restriction is. All right, well, hopefully this will help covering, doing it algebraically, finding the inverse, taking a look at it graphically, and then also understanding the domain and range. And I gave you 3 different types of functions, so hopefully it was a good variety. And I will definitely see you on the next video.